Hello Trig, we're in 9.2, working with a couple pieces of paper, one that'll have a page I Xeroxed out of the book, one that has my own notes, one that has like a grid that I made on Excel that starts with a thing about fronds and trees. So first I'm on the My Notes paper, just letting you know, we're talking about three main words with statistics. I usually do a statistics chapter in Trig because that's one of the more common classes you might get roped into in a college setting. So give you a little preview here. If you like this chapter, go take statistics in college. If you hate this, then when they try to put you in there, see if you can get into something else. But there's three main words today we're talking about, which are all easy ideas. Some of the problems, they'll find ways to make giant lists to make our life harder. But if you're given a list of numbers, there's three main words that we've talked about other years. Mean, which is just a synonym for the average. The median, which is just the middle number in a list, if you put them in order from the littlest to the biggest. And then the mode, which is just the most common of the items. So this first list that I'm throwing you, for us to figure out the mean, we just do the average like you've been doing since elementary school. You'd add these numbers all up. If you add those numbers all up, that adds up to 40. You would divide by 1, 2, 3, 4, 5, 6, 7, because there are 7 numbers. Grab your calculator, 5.71-ish, round it to the hundredths place, I guess, if you need to round. The median, they're already in order. Every list I think they give you is in order from littlest to biggest. So we could discard the 2 at the end, discard the next 2 in, discard the next 2 in, 6 is in the middle, so 6 is the median. If I gave you a list like this, took away that first number, and there isn't a true middle anymore, these 2 are at the beginning and end, those 2 are getting toward the middle, these 2 sort of share the middle, you'd have to average the 2 that share the middle. For this list, we'd have 6.5 for the median. For the mode, we're just looking for what's the most common, and the only repeat I have here is the 7, so the 7 is the mode. I'm not going to make you draw any histograms, anything in the homework about histograms, just ignore that. But if they ask you to draw a histogram, it's just a bar graph. So if I wanted to draw a bar graph for this, I have a 3 because I have a 3 in the list. 4 makes me put 4, 5 because of 5, 6 makes 6. 7 I did a double stack because there were 2 7s. And then 8 would be in the histogram. They're not all going to be that easy, but the idea is that easy. The mean is just the average, add them up, then divide by a count of how many you saw. Median is just the middle of the list. The mode is going to be the most common in the list. So if we take a peek at the book on page 272, they have a table where they're talking about somewhere in a nursery, which is a plant store as well as a place where babies may be, but they don't mean in the baby sense, but in the plant sense of a nursery. They have a bunch of different trees that have leaves on them, and they're counting up the leaves and trying to figure out basically like the average, the mean, and the median and the mode number of leaves on these trees. So instead of giving, they have 50 trees at their place, so instead of having a list like 1 leaf, 1 leaf, 2 leaf, 2 leaf, 2 leaf, 3 leaves, 3 leaves, 3 leaves, 3 leaves, 3 leaves, 3 leaves, and writing out a list of 50 numbers, they've organized this into a table. Since there are 2 1s, they made a little table where for 1 leaf there were 2 items. There's 3 trees that have 2 leaves apiece, so they made a 2 column that has a 3 in it. 2, 3, 4, 5, 6. There's 6 that had 3, and then I lost interest in making the list. But this table is describing to you that for 4-leaf type trees, there's 11 of those. There's 8 trees that had 5 leaves, and the leaves they're calling fronds, F-R-O-N-D-S. There's 12 that had, line these up a little bit better, 8 with 5, 12 had 6, 5 had 7. There are no trees with 8 leaves, so somebody shows up and wants an 8-leaf tree, they're out of luck. There's 2 trees that had 9, and the one leafiest tree had 10 leaves on it. So when they give you this information in a table, it's a little more complicated than it is when they give it to you in a list, because you're going to have to get a little bit organized with the table. But it's certainly better than me sitting here and writing out a list of 50 numbers. I had no vision for writing out a list of 50 numbers, and I don't think you would either. So what we're always going to do when they organize this stuff in a table for us is make a column where we do the item, like the leaves, called fronds, times a number called the frequency. The frequency was counting how many trees we put. So on the spreadsheet paper that I gave you, you can see there's a whole bunch of empty columns, and we'll come back to this paper tomorrow when we're in 9.3. We'll use this for 9.2 and 9.3. But the first empty column, after we see, I had a column on the paper, it was labeled trees, but frequency is just a synonym term for a count of how many items you had. In this case, it was trees. We could make a column here now for the fronds times the trees. For us to figure out the average number of leaves, we have to figure out first the total number of leaves. So if we had 2 trees that each had 1 leaf, we need to multiply 1 times 2 and get 2. Take 2 times 3 and get 6, because there's 6 leaves off of these. 3 times 6 is 18. 4 times 11 is 44. Just multiplying on, down, 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 down. To do the average, we're going to need to add up all those numbers. If we add up all those numbers, I am showing a 245. We also need to count up how many trees there are. But in a way, and I'll tell you why we're doing this in a second, we need to figure out a thing called the cumulative frequency. That's how many trees you've encountered so far. So off the first list, there were 2 trees, so 2 so far. Then there were 3 more. 2 plus 3 is 5 so far. Then there's 6 more. The 5 I already had, plus the 6 from over there, now there's 11 trees so far. We could see that in the list, and now my list is no longer helpful. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 trees when we run out of the 3s. 4s, there's 11 more. 11 and 11 is 22. 5, there's 8 more. 8 on top of 22 is 30. 12 more gets us to 42. 5 more gets us to 47. 0 more sticks us at 47. 2 more, we're up to 49. 1 more, we're up to 50. We have 50 total trees. So for us to do the mean would be the 245 total divided by the 50 trees, and that would get us a mean of 4.9. If I want to do now the median would be the middle of the list if I continue to make this list. In making the list, we'd end up with 50 total items, and I didn't have the patience to write 50 total items. With 50 total items, the middle of the list would be the 25th and also the 26th sharing a position. If you have an even amount of items, there isn't really a truly middle location. So you'd have to cut that in half. 25 is half of 50, but also the next item up. If I had 40 items, I'd be looking at the 20th, but also have to think about the 21st, because there's, for an even amount of items in a list, the middle of the list, there's like sort of 2 numbers there, so we have to think up 2 of them. So here's where we're going to use the cumulative frequency. We're trying to think who is in the 25th and who is in the 26th position. When we get to the 2nd position, that was the end of the 1s. The 5th position was the end of the 2s. The 11th position is the end of the 3s. The 22nd position would be getting close to where we are. That's where the 4s would end, is after you've encountered 22 trees. So then tree number 23, 24, 25, 26, 27, 28, 29, and 30. All of those trees through most of the 20s up to number 30 they're all the type that would have 5 leaves, which makes the median be 5, because the middle of the trees would fall in the section where there were 5 leaves per tree. For the mode, we just have to look for who's the most common. So 12 was the champ, so 12 is the most we see. That makes the mode be 6. A third type of example that they'll do, and now I'm using my Xerox page from the book, we're going to have to make our own table by counting and seeing how many times the things are on there. So when I look at this little list of numbers in the part titled Example 2, which if you misplaced that paper in the book, it's on page 274, it's in there. But we need to go through this table and count how many different times these things occur. So there's a 0.3, a 0.4, a 0.5, and a 0.6 are random numbers assembled into this table. So we'd have to count how many 0.3s are there. You go through, you count them up, and there's going to be 6 of those. 0.4s, there's going to be 4 of those. 0.5s, there's 4 of those. 0.6s, there's 4 of those, and I forgot a second, there's 0.7s there too. There are 2 of those. Before you advance through the problem, I would make sure you have all the numbers accounted for. I'm going to do a cumulative frequency now for 2 purposes. 1, it'll help me do the median eventually, and 2, it'll make sure I have all the numbers. So 6 so far, 4 more gets me up to 10. 10 plus 4 more is 14. 14 plus 4 more is 18. 18 plus 2 more is 20, and that's good that we have 20 numbers because it said that we are going to have 20 numbers. So for us to do answers, we could already do a couple answers. You don't have to do these in any particular order. The most anything we had, there were 6 of these. So 0.3 has to be the mode. Middle of the list, with 20 items, we'd have to think about the 10th, because half of 20 is 10, who is the 10th item, but also the 11th. Okay, our 10th item, item number 10, is where the 0.4s came to a conclusion. The 11th item would be in the next line up, which would be a 0.5. So we need to average 0.4 and 0.5. The median is then going to be a 0.45. Then to do the mean, we're going to have to do our multiplication. 0.3, there's 6 of them, that's 1.8 total. 0.4 times 4 is 1.6. 0.5 times 4 is 2. 0.6 times 4, 0.7 times 4, add that all up, and that should all add up to 9.2. To do the average, 9.2 divides by 20, and it would be a 0.46. Sometimes the answers are the same, mean, median, and mode. Sometimes they're all different. There's nothing really special about it. If it is or isn't the same, it doesn't make a difference. The last problem we're doing, there's this example 3, which is on the next page up in the book, but is also on the notes, that we're again going to make a table, but we're going to sort these numbers into classes, okay, groups. So the smallest group of numbers to look for on this table is the 40s. If you skim through for your 40s, there's only one number in the 40s. 50s, there are no numbers in the 50s. 60s, there should be 6 numbers in the 60s. 70s, there should be 27. 80s, there's going to be 22. 90s, there's going to be 4. A lot of your time in the homework is going to be spent just counting. It's not a real involved homework in that sense, but it'll take a little time to just count how many of these things that there are. For this one, before I'd advance any farther, I'd make sure I have all the numbers accounted for. So I'd recommend cumulative frequency coming early in the process. So 1 so far, based on the 1, plus a 0 is stuck at 1, Plus 6, we're up to 7. Plus 27, we're up to 34. Plus 22, we're up to 56. Plus 4, we're up to 60, and that question said there were 60 numbers, so we're good. We could do easily, probably the easiest answer is the mode. Most common is the 70s, because there were 27 of them, that's the most we had, so mode is the 70s. The median is probably the second easiest. Okay, with 60 numbers, cut that in half, and we'd be looking in the area around number 30 and number 31. That is going to be part of this line that also includes the 70s. Because when we wrapped up the 60s, we only had 7 numbers. And then the 8th, 9th, 10th, 11th, 12th, all the way up to the 34th, those are all going to be in the 70s. And we're only looking at position 30 and position 31 to be halfway through our list of 60. That's going to be all in the 70s. To do the mean, we have a little bit of a different trick on this one. We need to do a multiplication problem. Like here we did 0.3 times 6 and got that worked out. Here we can't really take the 40s times 1. We need to figure out what's called a representative number. If you travel from 40 to 49, the best number that represents that whole chunk would be the number right in the middle there, which would be 44.5. For the 50s, 54.5, 60s is 64.5, 74.5, 84.5, and 94.5. We're going to have to multiply these, and I have them written on the paper I gave you, so I don't know that I necessarily, well, I'll just write them down anyway. We'll go 1 times this is 44.5, 0 times anything is 0, 6 times the 60s is 387, 27 of those 74s is 2011.5, 22 of those 84s is 1859, 4 of the 94s is 378. Add these all up. These all add up to 4680. Take 4680 and divide by 60, and that'll shoot you a 78. If they ask you in the homework what the true mean is, to do the true mean, you break your calculator out and you would add up 60 numbers and divide by 60. Kind of time consuming, but that's kind of how stat is. Statistic stuff is usually not super complicated, but it's just there's time involved in just crunching numbers. But the true mean, the actual mean, is 77.73. When we group these into classes, that gave us an estimated way to do this in a way that's maybe a little quicker. But the true mean, 77.73 instead of 78. Homework off of this is, I don't have it written down, but the syllabus we know, I think it's a 1 to 8. 276, I believe, is 1 to 8. So email me if you have questions.